I will look at two examples because of the time that I'm given, and we'll dwell more on the second example because of the work of ICPAC on climate services. So I will start off by defining Indigenous knowledge systems. So Indigenous knowledge and Indigenous knowledge systems are looking for the knowledge that has been created and developed by societies with long histories of interaction with their natural surroundings. So this is knowledge which is developed by a community through living in a certain region, their cultures, the things they do, that end up creating a system within their region, within their area that they are working with. Now, therefore, it is basically locally based, grounded in a particular culture and the area, the geography itself, developed through engagement with the environment. And there's a lot of trial and error to find out what really is working and what is not working. And it is developed particularly for that community's needs. And the way this is moved along, the way people learn this indigenous knowledge is through oral interactions and through mimicry, through practical application, a lot of apprenticeship. If there is a particular skill that they develop, they would have an apprentice to learn that skill to pass it on. Otherwise, it's something that people know generally within the community, and it's passed on through people talking to each other and all that. And therefore, it has no theoretical grounding. Modern science, I will call it modern science for a lack of a better word, does a lot of theories and a lot of repetitions, evidence-based and all that. But traditional indigenous knowledge does not have a lot of grounding in theory. And that's a big difference that is between the two knowledge bases. Now, for most local communities, this knowledge informs decisions about their day-to-day life, their planning, and everything else. And therefore, it is very appropriate for local sustainable development. If it's the knowledge that they use in their daily lives and they want to have a sustainable development, then this is the one that would really help in doing that. And adaptation is also a developmental issue. So if this is the knowledge that can underpin local sustainable development, it can also really support adaptation. However, the term indigenous is sometimes difficult to handle. Who is indigenous to a particular area? So the use of that term is sometimes a bit difficult, and we end up having several terms that are used instead. So we sometimes talk about local knowledge or traditional knowledge, so that we do not strictly talk of indigenous knowledge. Furthermore, the term indigenous sometimes is not very acceptable to some people. So through this presentation, I will be using local, traditional, indigenous knowledge sometimes interchangeably, but meaning the same thing, okay? So let me look at the first example that I talked about. We have indigenous knowledge systems and everything else concerning agriculture and food security. We do know that we have a lot of climate variability or climate change impacts on agricultural biodiversity and natural resources. Now, these impacts are so hard on a lot of communities that rely on natural resources. And quite a number of our communities in Eastern Africa rely on natural resources. They don't rely on anything else. And this is more so for the marginal ASALs, arid and semi-arid lands. And in these places, you get a lot of subsistence farming going on. And that the subsistence farming is so reliant on rainfall, for example, and the farmers have to deal with droughts. They will have to deal with changing growing periods, more frequent extreme weather events, and spreads of pests and diseases. These are issues that they will have to deal with, and they need to have some form of basic knowledge to be able to do that. And we have these crops that are called neglected and underutilized species, or sometimes called orphan crops. They can help address these impacts and enhance the adaptation capacities of these communities that we're talking about. Now, a very wide range of those crops are grown by local communities in the marginal areas. These crops are actually sometimes referred to as traditional crops, and they are adapted to the regions where they are grown. They are very region specific. So they have been surviving the climate of those particular regions, but for some reasons, they have been neglected and not used so much. But they can contribute significantly to the livelihoods of the farmers within these areas. And with that, it can help them manage their economic and environmental risks, and thereby support adaptation. So if those crops can be encouraged, then they present an important option for adapting to agriculture. Now, the indigenous knowledge about the use of these crops, there is particular knowledge about the use of those crops, and then the genetic diversity of those crops are critical for sustainable food and agricultural systems at the local levels. So the crops are used in various ways, and over the years, knowledge has developed on how to use them. And if we utilize that kind of knowledge, then we'll be able to at least start fighting against the impacts of this climate change. A lot of these crops are produced by women. They produce, process, and trade these crops. And if we encourage this, then we'll be empowering the women. And we know that if you empower a woman, you empower community, and that would help in adaptation also. Some of the crops I'm talking about are, you have finger millet. I know a lot of people know this, but in case we have people in the house who do not know them, I'm just going to show them a few examples. We have pearl millet, we have pigeon peas, we have cowpeas, which looks like this when it's growing, and then you have the peas, you can get them from there, and that's the actual cowpeas that you need for your food. We have cassava, and then we have sorghum. So using indigenous knowledge, applying indigenous knowledge on how to use these particular crops can help us in adaptation. So there is one way in which you can use indigenous knowledge in supporting adaptation to climate change. The next example that I'm going to give is based on or focused on early warning systems and early warning, particularly in terms of climate and seasonal forecasting. It is important for us to do this because the farmers are reliant on rain-fed agriculture, and therefore prompt and accurate information about the coming season is very, very important. An early warning system has 4 components, and we have risk knowledge component, warning service component, dissemination, and adoption and use of that information, or capacity to use that information. I'm going to look at each of these components and look on one side, what I'm calling the modern science, and how can traditional knowledge help that modern science so that we get a better product or a better adaptation coming out of this. So when you talk of risk knowledge, we are really talking about you're staying in a certain community. What are you exposed to? Do you know those hazards? And do you know how vulnerable you are to those hazards? What are the patterns and trends in those hazards? When I talk about hazards, in this case, I'm talking about, say, flooding, say, droughts, and so on and so forth. Do we know this? Do we have the maps and the data available to do that? So the modern day science would do this by looking at long-term historical data. And this example would give you periods of droughts and periods of floods, or to a lot of rains. And therefore you can be able now to start seeing the cycles. When do we expect droughts? When do we expect to get the cycle? So using this data, you can be able to start planning on the cycles that you're going to go into. And this is an example where we are now looking at rainfall through the years and seeing whether the intensities are increasing or not increasing. So that's the approach that you get from the modern day science. However, we can use indigenous knowledge in this analysis also. And this is basically based on collective memory. How far back can they go, and can they be able to tell you what episodes they had for droughts, what episodes they had for floods, and therefore you can be able to start building a picture. If you combine that with this, then you start getting a better picture of what's happening within that area. Remember, the problem with the MET data sometimes is the resolution of that data. We have a few stations and we have a larger area to monitor, and therefore the stations may not be so representative of the larger area to monitor. And so if you look at, you go to the community and you get their perception on rainfall trend, for example, you can be able to start talking about, now this group is saying rainfall amount is reducing. And if you look at that graph, we see a reduction in the intensities. So you start matching different types of data, and therefore you get a better look at what is happening there. The next component is the warning service or the products themselves. Technical monitoring and warning for the identified needs. You already know the hazards that you are there. You've seen that the area is prone to flooding or prone to droughts. Can we do a monitoring and warn for those particular types of hazards? So the critical issue here is, are we monitoring the right variables? Do you have a sound basis of making a forecast? Because here now we are talking about forecasting. So will that forecast be accurate, and can it be timely? And therefore you have again the issue of the resolution, which I've just talked about from the normal climate data, MET data. Are we able to give specific information to specific areas? So that becomes a bit of a problem, inadequacy in monitoring. And basically we get data from MET stations, something that looks like this, and then from satellites. So from satellites, you'd be able to cover everything, a lot of space, but the question of resolution, how much space are you seeing? How deep can you go into the area that you're looking at? The resolution can be 50 by 50 kilometers. Will that be useful for a farmer who has a small piece of land? That kind of thing, that's what we're talking about. Now, when you come to indigenous knowledge, they collect data from the environment, from trees, from animals, from all those sorts of things. And then they do this kind of stuff. I'm sure you've seen this. So this gentleman is also monitoring the environment, is actually blowing bubbles, which is not very visible here. And then he's seeing how long those bubbles last before they burst. That has a lot of science in it, because we are talking about expansion of the bubbles, and then the availability of moisture around the bubbles, the pressure, and all those kinds of things. So they also collect data, and that data would give them their forecasts. This data would give the MET services their forecasts, and ideally the two forecasts should match. If you have that forecast ready, then you need to pass it across to the users. So that's, we're talking about dissemination. And dissemination has issues of understanding also getting involved. So do the warnings reach those at risk? Now here we are talking about the channels of dissemination. We have radios, TVs, and all those kinds of things. Are all small-scale farmers able to get the information through those channels? And this is where now we're saying if you get involved with local and indigenous communities, then you can tap into their communication systems. And since you are already collaborating, you'd be able to pass your information through them to the community. So that would be a plus in using their system. Do the people understand the warnings? Now, I will talk a little bit about this again a little later on. And actually the second one, do they contain relevant and useful information? So I've just talked about the resolution. The stations are not enough. The resolution of the satellite data is also a little coarse. So is that information really useful for the farmer who has a very small piece of land? But I will talk a little bit about those two again when I'm looking now at the last bit, the last component, the component of use of that information. Will the users, will the farmers adopt and use that information? So we are talking about now, are they going to be able to use that information? So they need to have the knowledge and preparedness to act. And that requires a number of things. The first thing is, if the information is coming from the Met services, do they respect the Met services? We are talking about credibility here. We are talking about trust issues. And basically, I don't know, a lot of us believe that Met is just a game of chance. So you get a lot of jokes being passed around about how this is done. And these cartoons show some of this. Some people think it's just a heads or tails thing, or when they are preparing the weather product, the one person looks out of the window and then tells the person who is in front of the TV cameras, it is raining now. So yes, we are going to have rains. The issue of trust, is it there? How can we be able to surmount? How can we be able to get the trust of the communities? Now, what I'm saying is, if we are coming together with the indigenous knowledge people, the local people, in developing the warnings that we want to disseminate, that process will start generating some trusts with the forecasters. Now, if the community has been relying on the indigenous forecasters to do that, because we have some societies that actually have meteorologists doing the forecasting, then their trust in the Met forecasts would start rubbing off on the communities, and therefore the trust can be built up. Do the communities understand the warnings? We normally have these diagrams being given around. The diagrams look nice. Do they understand it? We have, there are a lot of the information is given on this legend. What does it mean? How does it affect the users? Is it a product that they can easily understand? So now here we are saying that using the local knowledge, and the local knowledge that we are now referring to here is not just the local indigenous knowledge, but local agricultural knowledge, for example, from the local agricultural extension officers. You are able now to convert this map into advisories that can be used by the farmers, and therefore it becomes useful for them. And finally, do they have the capacity and know-how to act? So this now goes back to the issue of the advisories. It's easier to act on the advisories than to act on a map of temperatures or a map of rainfall. The advisories would match the expected rainfall with a certain type of crop to be planted. And therefore, for the community, it becomes a lot easier now to act on that information to do that. But there is also the issue of capacity to act. Now, that capacity to act requires some capacity building on the community, empowerment that would be required. And this may not be very easily done, but by bringing in development partners or issues like that, then the government, the county governments can be able to develop their development plans along those lines. And so it's a collaborative effort for us to do this. That's the approach that I'm trying to promote. We are not looking at the local indigenous knowledge in isolation. We want to have all those put together and have people discuss them. Now, in conclusion, yes, indigenous knowledge systems can enhance adaptation to climate at the local levels. That is very true. And through this, we can bring the community voices to the table and therefore be able to plan and implement relevant adaptation strategies. The key word there is relevant. If we are looking at information that you are getting from data which may not be consistent with what is happening at the ground, then the adaptation strategies that would be developed may not be relevant to that community. So involving them, engaging them in that development really helps in getting the right thing. And then on top of that, we'll be able to tap into some of the knowledge that they have, some of the processes that they have developed over the years to help us get through. We also need to further these orphan crops. The orphan crops will be impacted by climate change. And if they do not get developed further, then they will not be able to survive. And so breeding, crop breeding for these crops would be very, very important. This has been a little slow, but the process is going on, and there are organizations and institutions that are doing this now currently. A major policy revision is required to make sure that this becomes sustainable. We are trying to change things, and if we don't have those regulations, we may not be able to sustain what we are talking about. So policy revision and formulation, revision or formulation is required for this. Thank you, and I hope I've not gone too far beyond my 10 minutes.